Hi everyone. In the last session we have seen transient time calculations for the drive operation. So in today's session we'll see the numerical. So the problem statement is a drive has the following parameters. Inertia J is equal 1 kg meter square, T is equal 15 minus 0.01 Newton in Newton meter, and a passive load torque of TL is equal 0.005 N in Newton meter, where N is the speed in RPM. That means here main torque is proportional to the speed and load torque is also function of speed N. Initially the drive is working under steady state. In order to brake the motor characteristics is changed to where T is equal to minus 15 minus 0.01 N in Newton meter. So in order to brake the motor characteristics has changed from T is equal to 15 minus 0.01 N to T is equal to minus 15 minus 0.01 N. Okay. Calculate the time taken for the motor to reverse. So the reversal process is also transient. So we'll calculate the time taken for the reversal by using the yesterday's derivation. Okay. So simple here. For the steady state speed, if you want to calculate the steady state speed, we got already motor torque, that is main torque, and load torque. Under steady state, the opposing torque for the motor torque is only load torque. So load torque is opposed by the main torque or motor torque. The remaining torques will be equal to 0. That is nothing but J into d omega by dt due to the inertia, due to the friction. All other remaining torques are equal to 0 under the steady state condition. Hence the equation will become T is equal to TL or T minus TL is equal to 0. Usually the torque equation is nothing but T is equal to J into d omega by dt plus B into omega plus TL. But here the torque due to the friction, the torque due to the inertia, both are equal to 0 under steady state. Hence T is equal to TL under steady state condition. So T minus TL is equal to 0. By substituting the above equation, that is T is equal to 15 minus 0.01 N and TL is equal to 0.005 N in this equation, we will get N is equal to 1000 RPM. Just only one variable, that is N. By substituting in this equation, by solving this equation, we will get the N. That N is equal to 1000 RPM here. So this is the initial speed. Before speed reversal, the initial speed of the drive is N is equal to 1000 RPM. Now the speed need to be reversed. That is nothing but N should become minus 1000 RPM after braking of the motor. So but the condition here is already the load is passive load. So load torque is not changing. By assuming that condition for the passive load torque after braking the motor, again under steady state, after braking the motor, again under steady state, what would be the speed that we need to calculate. Again under steady state, the torque equation will become T is equal to TL or T minus TL is equal to 0. Main torque has changed from 15 minus 0.01 N to minus 15 minus 0.01 N. That I am substituting here. Minus 15 minus 0.01 N minus load torque is passive load torque, so it doesn't same load torque 0.005 N equal to 0. From here we got N is equal to minus 1000 RPM. That means after braking, the speed need to be reversed from 1000 RPM to minus 1000 RPM. During this process, what is the time taken for this speed reversal process? That we need to find out. To find out that speed reversal time or transient time during that speed reversal, so when braking by reversing, so the another component will add, that is T is equal, from the equation T is equal j into d omega by dt plus TL. In the derivation also we have used the same equation. By comparing with the other components of the torque, the inertia is little higher, that's why we will include the inertia torque also during the transient operation. As reversing is transient operation, we will include this inertia component also. Hence your equation will become T is equal to j into d omega by dt plus TL. From that, if you rewrite that equation, j into d omega by dt is equal to T minus TL. In the derivation also we have used the same equation. So the same equation, instead of remembering the equation or derivation, simply we can substitute here itself. J into d omega by dt is equal to T minus TL. So from here, d omega by dt is equal to T minus TL. So T minus TL is nothing but after speed reversal T minus TL, right? After speed reversal T minus TL is nothing but minus 15 minus 0.01 n minus 0.005 n. So it will become minus 15 minus 0.015 n is divided by j. This j will go to the other side. Now you got d omega by dt is equal to this much. So if you want to, we need speed in RPM. Just you can substitute this omega is equal to 2 pi by 60. So 2 pi by 60 is the constant term that will come out of the differentiation, and it will go to the other side as a denominator. That is nothing but 2 pi by 60. That is nothing but pi by 60. So j will be multiplied with the pi by 60. Your left side term will become dn by dt is equal to minus 15 minus 0.0115 n is divided by j pi by 60. So now you need only time. So if you rewrite this equation, which is nothing but dt is equal to, dt will go on the other side, this entire components will come on the left side, or dt is equal to dn by solving these parameters. So pi by 30, j is nothing but 10. In the problem, j is nothing but 1 kg meter square. By substituting j is equal to 1 kg meter square, pi by 30, and by solving this in numerals, we'll get dn by minus 143.24 minus 0.0143 n. Okay, just use calculator and solve this equation. So now your final equation will become dt is equal to dn by minus 143.24 minus 0.0143 n. If you integrate on both sides, integration of dt will give the t, integration of this speed equation. So the limits are n1 to n2. We need to find out the limits. What are the limits? Here limits are n1, initial speed is nothing but 1000 rpm. n2, if you want to use n1 plus 95% of the n2 minus n1, that is also okay. By that you will get 900 rpm, minus 900 rpm. Otherwise, if you want to calculate a little more, so n2 directly, instead of considering n2 as 95%, as in the derivation 95% of the, or 0.95 times of the n2 minus n1, minus 1000 minus 1000, that is nothing, minus 2000, it will become plus n1. So it will become minus 900 rpm. Otherwise directly you can consider n2 is equal 95% of the final speed, directly n2, that is nothing but 95% of the 1000, that will become minus 950 rpm. Okay, so here you may get a little more time, but this is also fine. So minus 950 rpm is the final speed. Directly I am considering 95% of the n2. After speed reversal, the speed is nothing but minus 1000 rpm under steady state. So 95% of that final speed after speed reversal I am considering 95% of the minus 1000, that is nothing but minus 950 rpm. By substituting these limits in this equation, by integrating this equation, you will get the time. This looks like integration of 1 by ax plus b into dx. 1 by this, here x is nothing but n, integration of dx by ax plus b in this form. X is nothing but n. The differentiation of 1 by ax plus b into dx is nothing but 1 by a ln of ax plus b, natural logarithm 1 by a ln of ax plus b. So 1 by a is nothing but the coefficient of n, 1 by minus 0.143 ln of ax plus b, ax plus b. Just this limits I can substitute. N2 is nothing but minus 950, n1 is nothing but 1000. By substituting that limits in this equation, finally we'll get the time as 25.57 seconds. That means after speed reversal, to reach the speed from 1000 rpm to minus 1000 rpm or minus 950 rpm here, the time taking for that process is nothing but 25.57 seconds. So that's what in the problem statement they were asked. Calculate the time taken for the motor to reverse its speed. It is 25.57 seconds. So just you follow this derivation, that's it. Only one equation, that is t j into d omega by dt is equal to t minus tl. Just substitute under steady state. Initially what is the speed under steady state? After speed reversal what is steady under steady state? Initially what is the speed? After speed reversal what is the steady state speed? Use this equation, find the limits n1 and n2, substitute in this equation, use this integral formula and find the time, that is 25.57 seconds. Thank you all.